Hi, I'm Aaron from No Tech Space. Our latest flight actually went pretty well.
Wow!
Before we get to that, let's review the static fire that we performed prior to the launch. The purpose of the static fire was to see if we can get the second stage engine to light with our new inner tube design. The inner tube is intended to channel the heat from the first stage parachute blast so that it ignites the second stage engine. We wanted to make it a small diameter to reduce heat loss, long enough to channel the blast to right below the second stage, and we wanted it to be lightweight. This was our best inner tube design yet. It was well sealed to the first stage engine, and it was longer, thinner, and made out of plastic. The inner tube we previously used was cardboard, and it only reached to about 5 inches below the second stage. Reducing the diameter increases the velocity of the blast, which we thought would help the second stage ignition. However, the static fire did not go as planned. We decided to proceed with launch anyway. You might notice that we made a couple of additional improvements in the latest design. To improve stability, we removed the second stage fins and lowered the first stage fins even further below the center of lift. These changes seem to have helped a lot, as this was probably our straightest flight yet. Unfortunately, the second stage did not ignite. If you watch closely, you can see the rocket come apart into 4 distinct parts: the first stage, the second stage, and what are the third and fourth parts? We finally figured out that the topmost one was the first stage engine, and the one right below was probably just a smoke trail because it disappears a few seconds later. The engine was apparently ejected during the parachute blast, but why? When we were inspecting the rocket after its flight, it was apparent that the inner tube had melted. This probably happened during the static fire and it closed off the inner tube. This caused the pressure from the blast to have nowhere to go and it pushed out the engine instead. Either way, the rocket was already falling, which means we'll need a shorter delay time for burnout to the blast. Next flight, we'll use an ST's D12-3 for the first stage, which has a shorter delay time by 2 seconds, and will hopefully pop the blast before the rocket starts falling. The new inner tube will probably be made out of thin metal so it can't melt from the heat of the blast. We're getting really close to finally doing this, so make sure to like, comment, and subscribe, and we'll see you next time.